Welcome to the free drawing creation from your 3D models with SOLIDWORKS webcast. My name is Bill Mitchell and I'll be doing the webcast today. Some of the stuff that we're going to cover in this webcast is kind of an overview of the drawing tools within SOLIDWORKS 2011. Some of that's going to include using model item dimensions in drawings. Model items are basically the dimensions that you assign features inside of a 3D model. You can leverage that information inside of your drawing files to minimize the amount of work, and you can also edit those directly. So I'll show you how to do those or how to use those features. You can populate annotations from file properties, so any of the metadata or information attached to a SOLIDWORKS part file or assembly file can be put into your drawings to minimize the amount of data entry and also to make sure that there's consistency from the part model into the drawing files. And then another thing we're going to take a look at is the bill of materials and assemblies and drawings. So we'll go ahead and get started. We'll switch back over to SOLIDWORKS. And I've got a model that's already been started. And if you recall, as you go into a sketch, as you start a model, you assign a value. If you double click, or as you're creating dimensions, there is a button here that says Mark Dimensions to be imported into drawing. Now, in order for these drawing files or these dimensions to be put into the drawing files, this has to be enabled. There's always a way to put a dimension in just with a standard annotation within SOLIDWORKS, but using this method can minimize the amount of information that you have to do or amount of work you have to do. And it also allows you to directly edit the model within the SOLIDWORKS drawing file. So just do a quick roll through of the model to see how this is created. So you've got extrusion, then a fillet, boss extrude, another fillet, um, shaft undercut, and then a chamfer. Notice down at the bottom we've got a cosmetic thread that should come into the drawing as well. So what I'm going to do in order to start a drawing is I can file, make drawing from part, split screen. So I'll just go ahead and select the C size print. So now whenever you start a drawing file, over on the left side you've got sheet format. Down at the bottom you've got different sheets, so you can create a multi-sheet drawing. Um, on the right side I have a view palette. Now the way that you model a part within SOLIDWORKS becomes relevant within the drawing context because what you use as front, top, and right plane are going to be used for this particular view palette. For example, if I draw something from the front plane, notice that I've got a in parentheses next to some of these views. That's indicating that there's an annotation on that, so that anything that was modeled or sketched on that view is going to have some dimensions that I could project. So I'm going to import my annotations, and then I'm also going to tell it to auto start projected views. So that means that whenever I drag and drop a drawing view into my drawing, the type of projection is going to use is going to be third angle projection. So I'm going to drag and drop that in. It automatically puts in some dimensions, but it also keeps the drawing, or it jumps directly into the projected view mode, and I can just drag and drop another view, and then maybe one down this way, and then by holding my control key while I place this view, I can also place an isometric view. Maybe I'll go ahead and turn off the axes, and I think sketches. Oh, and also have the center lines automatically inserted, so I can just delete those guys. So if I want to have, other than just a regular drawing view, I can have this be a shaded view, so I can show this as shaded with edges. I can show with hidden lines visible. I can also right-click on this and then show my tangent edges rather than having a solid line. Maybe make them a dashed line to kind of differentiate between where a curve starts. It's nice to have those edges there, but you don't necessarily want those to be a solid line. Zooming in, you can see that I've got some different dimensions. I can pull this guy out. So this dimension, the way that this was created was with a chamfer feature. The chamfer feature shows, it has a depth and an angle. I may not necessarily want that to be my value, so I'm just going to delete that. And I'm going to insert another dimension. So if I come right click, create a chamfer dimension, I can just select two edges, and then it's 45 degrees. Where did that go? Oops, I think I canceled it, so I'm going to come up. Another way to do this is to, there we go. Let me pull this back in, change my arrowhead direction, just do a little bit of cleanup. There we go. So now if I want to edit this, I can directly edit the information in my model by just double clicking. It brings up a modified dimension. So if I want this to be maybe 45 millimeters, I can rebuild this, and notice how the model changes. So it's directly communicating between the SOLIDWORKS part file and the model. I can also cancel that, rebuild it, and it goes back to its former size. If there's a dimension missing or something that I want to annotate that wasn't necessarily part of the way that I modeled it, I can always create a reference dimension. If I select a dimension, the view palette comes up, and this is something that was introduced or was improved upon in SOLIDWORKS 2011. There's a lot of these different types of annotations. Rather than having to come over to the left menu and do a lot of mouse drags, I can just select a dimension, pop the screen open, and I can put dimensions anywhere up, above, below, left or right of the text, or I can even put this in parentheses, those types of things. Notice that it also snapped back into position. Because I enabled rapid dimension on these, it allows the dimensions to automatically be placed relative to one another. So if I have a dimension, for example, that I want to call out the length from this edge to the bottom of this extrusion, I have this rapid dimension tool that allows me to automatically shift the existing dimensions out so that I don't have an oddball looking dimension stack. So now looking down at the title block, if I come down, you can see that this information was automatically populated. I can always override this just by selecting it, entering in information, but let's take a look at how this information is actually populated. Within a drawing file, there's a couple of different elements. There's the actual drawing template. The drawing template is going to include your dimension, standard, unit of measure, fonts, those types of things, the general appearance. Um, the second element is the sheet format. A sheet format is a separate file so that you can have different sheet formats for different drawing sheets within the same file, different title block sizes, those types of things. So the way I kind of think about it is that my sheet format is very similar to my title block. So any of the annotations that I want to standardize are going to be in my sheet format. Coming in and looking at this particular dimension, if I edit this in a window, pull this back over, this doesn't really include the information new rod end. It's looking to the SOLIDWORKS file name of the model that it's pointed to, which is new rod end. So the information isn't directly entered. It's actually being pulled from metadata that's within the actual file. Same thing goes for this $PRP sheet. This syntax is indicating that whatever the first item is in this drawing sheet is where it's pulling its information. So to verify this, or to show you how this works, let me go back out to the sheet, back to my model. And if I come into my file properties, move this back over here, you can see that I've got the description rod end. Well, I'm going to call this alternate rod end. Go ahead and Control Tab back to my drawing file, do Control Q to rebuild, and you can see now that that information is pulled from the actual file. Um, the title block label, since this is pulled from the drawing file, the change that I made in the part file is um, making the information linked to the different name. You can see that there's a difference in the formats here. So if I go ahead and edit the sheet format, the author versus is the actual property that should have been changed. Um, so let's go ahead and take a look, going back to our list of topics. So we use model items and dimensions. We talked about populating annotations from file properties. Let's go ahead and take a look at some of the bill of material and assembly level stuff that we can do. So switching back over to SOLIDWORKS, go ahead and open up an assembly. So I'm going to go ahead and finish up this assembly. Notice that it does have a couple of configurations. Um, Open JAWS, I can move this back and forth. I'll go ahead and finish up the assembly real quick. Hide this guy. I'm going to put in my new rod end. Go ahead and make this into position. And I believe there's a link that I need to find here. Actually, I know exactly where the file is. I don't need to search for it. So I'll come back over here, browse into my vault. I believe that's what I'm looking for. Let me try this again. There we go. That's a little better. So I won't worry about completely filling this out. I think the only thing left to do is I'll just go ahead and put a mirror feature in. Okay, so now I can move this in and out. Coming back over to open JAWS. Actually, I won't worry about fixing that for right this minute. So now coming back to my configuration, going to my exploded view, I can go ahead and use this exploded view in a drawing file. Go ahead and right-click, edit this feature, and I'll add a step for these guys. Move this over a little bit. That should be good. And then maybe include an explode line sketch for a couple of items just to show how that works. Flip the direction of this guy. So whatever I do in this level is going to be shown um, in the drawing file. If I want to edit this, I can just say delete that. And at the end of it all, this is just a 3D sketch. There's not much to it. There we go. Now I can collapse this, expand it. I can also, if you've not seen this before, I can animate the explode, and it shows it step by step exactly how this thing comes apart. Little animation bar here. So now I'm ready to go ahead and create a drawing. There's a couple things that you can do as far as bill of material goes. One of the ways that SOLIDWORKS creates a bill of material is that it goes through and looks at your assembly tree and the sequence in which you assembled things is the way that it's going to populate the bill of material. Now I can create a bill of material in a drawing file, but I can also do that directly in the assembly and then reuse this bill of material in the drawing. So for example, I'll go ahead and create an indented parts list, detailed numbering, and I only want the default configuration. There's a lot of different different ways that I can create the item numbers and so on, but I'll also go ahead and accept the defaults. And it's nice to have this bill of material directly in the assembly. For example, I can just right click on this, save this BOM out as a PDF, DXF, Excel, spreadsheet, those types of things, without ever having to create a drawing. So that's kind of a nice tool. But if I want to get the bill of material looking like I want it to, I can just do that in the assembly, make drawing from assembly, go ahead and accept. Accept the view. And again, going back into the view palette, you can see in this instance, I don't want to import all the annotations because that would be a little bit crowded. But I'm going to go ahead and create a front view. And a top view. Going back into this, looks like my assembly is a little bit out, so I'm going to spread this up a little bit. So now notice that whatever my position is in this assembly file, when I switch back to the drawing, that overlap that I showed is now spread apart a little bit. I can go ahead and put in just regular dimensions rather than using the model items, because this is all in assembly. There really isn't a model item dimension that I can use because each one of these was modeled in and of itself. So in this case, I would want to create this, maybe select my dimension. Something like that. If I want to create a isometric view, select the isometric predefined view. If I right click on this, go to its properties, I can show this in its exploded state. Pull this down just a little bit. Now in this case, I can go ahead and insert a bill of material. Now there's a couple of ways, again, as I mentioned earlier, how I can do this. If I want to go to my tables, bill of material tables, notice that I can create a new table, copy an existing. If I copy the existing, that basically creates an instance of it. It isn't talking back and forth at that point. So let's go ahead and create a new one because I don't necessarily have enough room on this drawing for an entire indented. I'll just accept the top level bill of material versus the indented bill of material. Go ahead and put this over here. So now notice that whenever I select on a line item, if I move this over just a little bit, I should be seeing them highlight. Select on the models. So now notice that this particular item is a subassembly. So now when I select just that part, it doesn't show up. Now if I were to take this bill of material, call it an indented bill of material with detailed numbering. Now when I select this component, it shows up. So since this is a subassembly, that feature or the dynamic highlight only works. It doesn't select it as on a subassembly basis. Actually, there does appear to be enough room for this. So I'm going to move this guy over. So now notice that whenever I double click this, there aren't any balloons. One of the nice things about a bill of material is that I can auto balloon this and it just pops those items in. I can tell that I want a circular pattern and then maybe move this in just a little bit. Oops. Accept that and then move this guy in. So now I've got a nicely ballooned item, a bill of material with all the descriptions, pulling the information directly from the models versus having to go through and manually edit all that information. I also have reference dimensions for the entire assembly envelope without having to go through and create some sort of elaborate geometry. Now if I want to do a section view, go ahead and start a new drawing file, and then I'll do a section view of my assembly. I'll say I'll initially put in a bottom view, but I'll make this the top view instead. Doing section views within SOLIDWORKS is very simple. I can just go in, sketch a line, you can quickly see that a detailed section view has been created with all the different hatch patterns. The hatch patterns are going to be material specific. So for example, if this particular part is made out of aluminum, then it's going to pull that directly from the model. If I go through and open up this part file, add a material, I'll just say that this is going to be cast alloy steel. If I edit my material directly in the database for cast alloy steel, my crosshatch is going to be NC32. So now when I switch back over to my drawing file, see that the hatch pattern has changed. I can also override that, so if I want my scale to be a little bit bigger, or if I want it to be smaller, just to create a so it should have updated. There it goes. I can also create a shaded view of this guy, make things show a little bit of contrast, um, or not. That might be a little bit too dark. So now if I want to create a bill of material on this view, but I want it to be ballooned, or if I want to balloon items, I can double click this view, go to its properties, and I can tell it to, whenever I balloon an item, to link it to the bill of material. So rather than create a duplicate bill of material on this sheet, say I'm creating a document package and I want to be able to have my bombs and all my balloon numbers line up just for simplicity and consistency out on the shop floor, I can do that. So go to annotations, auto balloon. I'm going to auto balloon this view. So the things that are not shown in the other bill of material will be shown here. So for example, the battery, the housing, the clip, and so on. I can also still balloon items even if it's a redundancy. I can also attach a note. So if I've got a note and I'm curious what a given item is, I can select this, and I can link that directly to file properties. I have the option of linking the annotation to the current document, the model in view to which the annotation is attached. So I attached it to the face of that model, and say maybe I want to show the file name. So that pulls the assembly name. Um, if there's a particular view that I want, rather than having to go into the model, I can just place another isometric view. But I can also use the 3D drawing view to rotate this into place. So I want to show the bottom perhaps in this view. And I can save that, and I'll call this bottom. Put this back over. So now that stays. In creating that view, it actually dynamically reaches into the part and creates a saved view in the assembly file as well. So that's kind of what I've got to show for the assembly drawings. Let's go ahead and take a look at sheet metal drawings and some of the things that you can do with that. So if I go ahead and start up a new file, doing the flat pattern for sheet metal parts is something that is necessary at times, and SOLIDWORKS automates that process fairly well. So what I can do is just go ahead and create a simple sheet metal part. Won't get too bogged into that. So what I'm going to do is go ahead and convert this to a sheet metal part. First thing is I'm going to say that it's made out of plain carbon steel. Going into sheet metal, I'm going to convert this. Say these are my bend edges. Something like that. And then maybe I'll put a hole through the center of this. So if I want to put a hole on this face, I'm going to select it, create a whole wizard hole, and maybe put a couple of tapped holes. And I didn't really have to flatten it to do this, but just to show that it was possible. Tapped hole. Go ahead and add the cosmetic thread, and I'll put a couple of these guys here. Put a couple of cuts in, since I've got this in its flattened state. And then I'll go ahead and fold this back up, collect all my bins, and so now I'm ready to do a print of this. I have some details over here that I wanna show. So the first step would be first to save this out. And then I'll make a drawing. So now with the sheet metal part, one of the nice things is I can just directly bring in my flat pattern. I can also show, I'll do that on sheet 2, but so I'll show the front view, top view, change my drawing scale to maybe be 1 to 4. So now since this face is sloped out, I can't really get a good dimension on these because it's not normal to my particular view. But what I can do is create an auxiliary view to where those will be normal. I'm going to go ahead and right click on this guy, break my alignment. Now I should be able to dimension this. And I'm also getting a good center point. So now I can those types of things, or I can even rotate my center lines as well. We just call these out from that edge. Or even better yet, use an ordinate dimension. I suppose that would make the most sense. If I come back in, do an ordinate dimension, define this as 0. So now I've got those ordinate dimensions, have those other dimensions. Go ahead and put in some other reference. So now as far as flat patterns, I'm going to go ahead and add another sheet. I'll right click on this, go and make this I'm going to turn off my display format and then maybe make this a size E. So now this is just a blank piece of paper. And the reason that I'm doing this is that I might quite likely want to save this as a DXF file. Make this 1 to 1. So now this, right click on this guy, go to my rotate view. And I can export this as a DXF file. So you can see my flat pattern brings in the bin direction, the bin line, the annotations. If I want to change this, I can just go into annotation, hole callout. And it also brings in all the information from the hole wizard file, so the quantity, depth, and so on. So that's kind of what I've got to show for the sheet metal side. Some of the other functionality that you can do with drawings is, alternate position views, those types of things. But I think this kind of gives you guys a good overview of what might be possible with SOLIDWORKS and leveraging the design data from the CAD models into a drawing file.